Okay, everyone. Today I want to continue our lesson. Our lesson is until 2.4. That's the inertia. So today we're going to go to 2.5. So this one I call you to download through the tutorial, through the Telegram. So from here for the student, you already for the start. Okay, let's say you don't want to refer, don't want to waste money. So that means you can see your computer. After that follow my lesson. If you want to write something, so better you go to print out first. Okay, so from here we start with the chapter 5, chapter 2.5, that's momentum. Okay, we refer here. This one is a sum of the short notes. Okay, first, okay, momentum we need to relate it by the two physical quantities. Okay, when I'm talking about momentum, okay, momentum must relate with the two things. One is before that I want to introduce what is that. Let's see first. Okay, first one they show about one of the small trolley. Okay, this one small trolley, they move with high speed. So from here they say, okay, this one is high momentum. Okay, another situation, they say this one trolley become larger, the mass higher. Then they say this one also is high momentum. So from these two situations, we can conclude the momentum is related with the speed. Another one is related with the mass. Okay, so this one is a momentum. Okay, let's see example here. Okay, in your notes. The first one, they say the object moving highest velocity, or you say larger mass, that's a large momentum. So there are two important things. There's a velocity, another one is a mass. Okay, now, phenomena. First one is a bullet. The bullet travel very high velocity. So this one, the value of momentum large. So that means velocity and momentum is directly proportional because both also high. Okay, the second one is a lorry. Lorry has a larger mass. Larger mass, they also say momentum should be higher. So should be higher means the mass also directly proportional with the momentum. So from here we find it there's a two important physical quantity, that is velocity, another one is mass. So from here we can write the definition for the momentum. That is product of mass and velocity. Product of the mass and velocity. Okay, so here conclusion, momentum of the object they define as a, okay, this one is a definition, you can highlight. Okay, product of its mass and also velocity. Okay, by using the word, by using the formula, okay, first one, momentum, the symbol is capital P. Okay, from here, mass. So mass is a M. Then another one, V stands for velocity. So from here, product of mass and velocity means multiply. So from here, P equal M multiply with the V. So we can short form, we can write equation P equal MV. That one is momentum. Okay, now we're going to see the unit. Okay, mass. Mass SI unit is a kg. So V velocity, there's a ms, the one. So when we both product together, so you find it kg and s negative 1. Okay, sorry, kg and s negative 1. So this one is a momentum unit. Okay, next, vector quantities. Momentum is a vector quantities. Remember what's a vector quantities? We got two. One vector, another one is a scalar. Scalar is a physical quantity. There's a without direction. That means they just got magnitude value. Okay, but this one vector means they both also have magnitude and also direction. So this one we call vector quantities. So for any situation, momentum, they go move in opposite direction, so you need to put negative. So that one is a vector quantities. Okay, so now we go and see the, okay, all the thing I explained for the characteristic for the momentum, all is here. Okay, you can refer the notes. Okay, then we need to go is example 1. Okay, let's see the example 1. Okay, example 1, there's a bullet. There's a bullet of the mass 0.01 kg. They move with the velocity 200 ms/1. What is the momentum of the bullet? So that means if you don't know how to do, we write all the information first. If you don't know, you draw. Okay, so from here, the first one we can say about the bullet. Okay, example 1, the bullet. Okay, now the bullet, they move. Okay, there's a 0.01 kg. Okay, the bullet. Okay, now they move how fast? Velocity is 200. Okay, so this one is the information, you get it? Okay, so from here the question what they want? They want momentum. So we write momentum P equal mv. So after that, P is m is a mass 0.01. Then velocity is a 200. So the final answer, when you get it, there's a 2. Okay, don't forget the unit. Unit is kg and s 91. Okay, so this one is a unit and also the answer for the momentum. So this one question don't have any opposite direction because you just got one object. You just move only. Okay, we don't have another object. Okay, now we're going to see the example 2. Okay, example 2 long a little bit. Okay, you see, understand the question first before you start to do. Okay, they said a trolley of the mass is 1.5 kilogram. Move with the velocity 4 ms per 1. One trolley, move with 4 ms per 1, hit a wall. So that means the trolley move only, the wall cannot move one. Okay, when they hit the wall, after they rebound, come back. Okay, along the initial direction, come back to the same direction, come back to the same route, but the direction is opposite. Okay, the velocity will become 3. So when you go faster, when they come back, they will slow down. Okay, now they want you to calculate 3 things. First, starting, what's the inertia? Inertia means starting momentum is how many? When you go, what is the momentum? The second one is final momentum. Final momentum is come back, when you come back. Okay, after that they ask you, what's the change of momentum? The total, they change how many momentum. Okay, so from here we need to do the calculation. Okay, now number 2. Okay, number 2, the info is a trolley. Okay, we draw the trolley. Okay, now the trolley, the mass is 1.5 kilograms. Okay, now they move. Okay, they move with the velocity 4. Okay, this one is a wall. Okay, they move with the velocity 4 ms per 1. Okay, after that, move until they hit. Okay, they move here, then they hit. They hit the wall and come back. Okay, hit the wall and come back with the velocity, there's a 3. Okay, so from here, either one should be the negative lah. So what we need to do, we take the, normally we take the final one. The final reading as a positive direction. Okay, what means the final as a positive direction? Okay, means now I want to go to right hand side. Final is the number 3. This one final. This one is the initial. So we take this one as a positive direction. Means the object now go to left hand side. We take it as a positive. Okay, another one. Now the object go right, we take it as a negative. Okay, so this one is direction up to you. Which one you want to take is okay. So from here, why later I tell you why I want to take the go to left hand side is a positive. Later we got reason. Okay, now we do the calculation first. Okay, the first one you want to find what is the initial velocity. Okay, initial velocity. So initial velocity is this part. Okay, this part. So from here we do the calculation. Initial velocity. There's a P equal mv. So there's a 1.5. Then multiply is number 4. Okay, so the answer should be 6 kg and s negative 1. Okay, this one why I never put a negative, because the question is a 1 by 1 to us. Okay, if the question combine to us, okay, initial, after that final, then changes, then the differential, then you need to put a negative. So the question now is 1 by 1. Our first one is how many, the second one is how many, so you don't need to put the negative. Okay, you want to put also can, then you need to explain now. If I put negative 6, okay, the object is moved to the left hand side. Okay, like this only. So from here, this one is a number 1, number 2. Okay, number 2, they ask final momentum. What's the final? Final is this part. So final momentum, the formula is the same. Okay, still 1.5. The mass cannot change 1. Okay, now we're going to see the velocity. Velocity is a 3. So I find it, number 2, they get it 4.5 kg and s 21. Okay, so this one is the final. Final momentum is how many? Okay, now the next one. change of momentum. Okay, remember change. When they say about the change, that means initial and final, you need to minus. This one we call changes. So normally we take the final minus the initial lah. So this one we call changes of the momentum. You also got changes of velocity. Change of velocity is what? V minus U. Okay, now momentum. Momentum is what? The formula? And V. So V, now we got 2V. One is this one. This one actually, initial we can call as a U, is it? U velocity. Okay, initial velocity. This one is a final velocity. So from here, later, V and U, this one we need to separate. Okay, now I clear the diagram. Okay, now we go to the number 3. Number 3, suppose the formula become P and V minus U. Okay, V is it? Now we got 2V. Because one is the initial, one is the final. So from here, if I follow what I write here, and just now I told you again, go to left hand side, positive. Okay, which one is the left hand side? Final or initial? Final. Final is go to left hand side. Okay, so positive lah. This is a positive. Okay, so this one is a initial. Initial is go to right hand side, is it? So go to right hand side, there's a positive, there's a negative. So from here, this one is a final. Okay, this one is the initial. Okay, so from here we do the calculation. Okay, mass is the same, 1.5. Okay, so final, what is the velocity? The final velocity is 3. Okay, go to left hand side, positive. Okay, remember, minus. Don't eat the minus. Minus not because of this one negative. Minus is a formula. So we put negative, put the minus here. Okay, next. Initial velocity where? This one. This one is the initial velocity. Initial velocity where they go? Go to right. Go to right, I take what? I take that's a negative. Okay, so I write -4. Okay, so final, what you see it? 1.5, 3 plus 4. Can you see they become positive already? So the final answer should be 1.5 multiplied with the 7. So 1.5 multiplied with 7 is how many? Okay, calculation please. So I take the calculator please. Wait. Okay, so the answer is 10.5. So from here I get it, there's a 10.5 kg ms -1. So finally, do you understand why I want to put the final as a positive direction? Okay, from here, do you understand why I want to take like this? Okay, I want to take like this because final answer is no negative. My final answer is positive. So I don't need to explain now. Oh, finally, the trolley is moving opposite direction. Okay, like this. Understand? So now, I reverse. I follow what you do before. I take right hand side is a positive. Take right hand side, positive. Okay, left hand side, negative. Okay, right hand side means initial. Okay, initial there's a positive. Okay, then the final is left hand side, so you get negative. Agree? So from here we can write the equation. Suppose it's a mv minus mu. Okay, mu this one. Okay, this one is the first initial. So I get it 6. Okay, after that I need to minus. Minus, then this one will become so minus and minus 4.5. Okay, so this one will become 10.5. Agree? So many of you, the problem is, okay, the problem is where? Oh, minus. Minus because of this one minus. So that's straightforward. 6 minus 4. So the answer they're getting how many? Okay, 1.5. So this one correct now? This one is wrong. This one is wrong. Okay, that is wrong. So what you need to do, remember minus. After that, the minus memang is formula. You cannot say, oh, the minus is a negative. No. Minus is a formula. Then your original final direction got negative, then you need to put negative go in. Okay, if you initial put in, then you initially put in. So either one, you take that is a negative. So you can get the answer. Okay, so this one is the example 2. Okay, so from here, this one is what I want to mention. Important, because many of them they do the wrong thing. They just assume, oh, B minus U, the minus is a negative. So the minus still minus. So the negative you just put in, then finally will become the plus. Okay, understand? Okay, so now this one is example 2. Then we need to go the principle of the momentum. Okay, so from here, let's see the application. By using the principle of conservation of momentum. The name is too long, but you need to remember. Because when momentum, they sure will ask what principle we're using for momentum. So you answer principle of conservation of momentum. First, we need to understand what is the meaning of conservation. Conservation means equal. That means the whole process, the momentum is equal. So we say conservation of momentum. Okay, so now we see the diagram. We got 2 figures here. One is the fireman, they hold the hose. Then after that, this one when they on the water to come out. Then when the water to come out, they are moved to backwards. Can you see? The water, when it just flow out, okay, you see the fireman. The fireman, they move more strength. The force is more stronger. Then you need to stand properly, then pull backwards. Okay, so now this one the question will ask. Collision and explosion. Figure A and figure B, they show about the firemen, they're putting out the fire. Okay, in the figure B, both of the firemen are through backwards. They move backwards. Okay, when the water at a high speed, they shoot up. So, the water and the firemen, the movement is opposite. Is it? The water to go to left hand side. Then the movement of the firemen, they go to backwards. So, that means the direction is opposite. So for this one situation, they ask you, why happen? Why this one situation will happen? You go forward, why I never go your forward? So I go backward? So this one is one of the questions that will ask about the momentum. So from here, we need to explain. So when you explain, you sure must bring the momentum to go in this whole concept. You cannot say, oh, momentum, because of momentum. So you need to explain, related with the principle conservation of momentum. Okay, now we're going to see the reason. Okay, water gushing out of the hose with the high speed. You must say the water go in front with the high speed. And also has a high forward momentum. When the water out, water got mass. After the high speeds are more. So that means they got high momentum, go forward. Okay, due to this, because of this one, 2 or more firemen, they are needed to balance momentum. Yes or no? Because I say conservation momentum. Conservation momentum means in front and behind, the momentum must be same. Now you just got in front. The water go in front faster. So the behind one must be supported, must make the momentum become balanced, is it? So that means the water go in front, high speed, high momentum. So that means at the same time, you want to balance the momentum, you must have the momentum go another direction. So that's the back side. So that means the firemen, now they create a high momentum also, but go in opposite direction. So from here they say due to this, 2 and more firemen, they are needed to balance the momentum by holding the hose tightly. One person to hold cannot. One person to hold, that means you will very fast to move to backwards, then you fall down. So they must more of the firemen to hold the hose. After that, they can stable. They can stable. After that, then forward momentum and backward momentum become equal. So this one is the reason why they need to hold tightly, using the more force to hold it when the water start to move up. Okay, now this one is the reason. So this one can come up for the process question. They just ask, okay, this one situation, then they call you using the principal constant of momentum to explain why this one situation will happen. So this one is one of the question. Maybe lah, they will come up. Okay, now we're going to see actual principal conservation of momentum. Just introduction. Okay, now we're going to see this one. Principal conservation of momentum. Okay, definition. Then the question should ask what's meaning of this one principle. So you need to give out the definition. So you write in full sentence. Because I not enough the space, I write in short form. Okay, first one. This one symbol means total. Total. Okay, semua. So from here, this one we call total momentum before collision. That means the momentum before collision means the horse and the water starting before that out. That means you hold the horse, then the water oil come out. That one we call before collision. Okay, so they must equal total momentum after collision. That means when the water just start to flow, that means the water momentum out and also the momentum for the fireman to hold the horse, that one the momentum must be equal to the water momentum. So that means total momentum before must equal total momentum after. Total momentum is how many? Okay, if I say the fireman, total momentum is a 0 when starting. Yes or no? Because no movement, what? The water not yet come up. Then after that, the hose don't have any movement. So this one is a starting. The momentum is a 0. So when I start, you can see movement already. Momentum move forward. The water move forward. Then after that, another momentum move backward, is it? So before that, I told you, principle, total momentum before must equal total momentum after. Before, I told you there's a 0, yes or no? Because both also no moving. But final, why become 0? You will ask me the question. Why become 0? The water go move what? Then after that, the hose will also go become heavy what? Why? I need to hold some more. Why become 0? Okay, I can tell you. Because your movement, you move backwards. Then the water is moved forward. Remember, momentum is a vector quantities, go direction. Move forward is a water positive. Then the move backward is another direction, go backward, that's a negative. So I say momentum it must be equal 0. So that means momentum for the water go in front, example 20 momentum. So that means move backward, the momentum sure also must be 20. So that's why the final answer is a 0. So this one we call it momentum, principal conservation of momentum. So this one is one of the example lah. So before we go that situation, we need to introduce 2 more. Okay, because just now that one the example, there's an explosion. So now we need to go, before we got 2 collision first, last one is explosion. Okay, so I want to explain the principle first. So this one principle, the situation like this. Can you see 2 ball? Okay, first and second one. Okay, this one, the 2 ball with different mass. Okay, they move to right hand side. Another one also move right hand side. This situation we call before collision, before the hit. Okay, so this one momentum you need to count lah. Before collision, what is the total momentum for this part? Okay, these 2 momentum is, you need to count M1, U1. Mass 1 and initial velocity for the ball 1. Okay, number 2, mass 2. Okay, mass for the second object and also initial velocity for the second object. So from here we write it, there's a M1, U1. Okay, plus together, M2, U2. This one is formula before collision. Okay, now we're going to see after collision. After collision, can you see both also separate? Both also separate. Okay, mass for the first object can change or cannot change? The mass is cannot change. Although you hit how many times, your mass also there. Okay, so from here, M1 sure the same. Okay, now, this one is M1. Okay, V1. We still write V1. Okay? Although I know V1 already is opposite direction. Yes or no? Okay, we do know. We just write formula first. Okay, we also need to plus. M2, V2. Okay, so the equation is what? Equal. Must write equal because you follow principle conservation of momentum. If this one question they give you all information, they just left V1. They say, what is the V1? Then you need to find out. I guarantee for you, your V1 answer should negative. You find the answer must be negative. Then you need to explain why. Because the object 1 after collision, they move in opposite direction with the initial direction. So this one is the answer. Okay, so this one is I want to using the diagram to explain what's meaning for this definition principle. Okay, total momentum before collision, this part, equal total momentum after collision. Okay, I said total, I didn't say separate. I didn't say momentum first object must before collision must same like the momentum for the first object after collision. I never say this one. I say total. I never separate one by one. Okay, so this one is the principle. Okay, then we need to go through two types. We got two types of the collision. Okay, let's see here. Type of the collision. We got two types. One we call elastic. Another one we call inelastic. Okay, now we go to elastic first. We see what means of elastic.